Yeah, these angles right here, the congruent angles are always going to be opposite to the congruent side, so they won't be marked. A lot of this unit I've been saying like, okay, you have to know how the markings work. Well, yes, for this one you have to know how the markings work, but these sides won't be marked. You just have to realize these congruent angles are opposite the congruent sides. The congruent sides of an isosceles triangles are called the legs. So if I say legs, I'm talking about the two congruent sides, not the other side that's not congruent. That has a different name. That other side is called the base. So you would have like, this is leg, leg, base. For this one, base, leg, leg. It's not always going to look like this where the base is on the bottom. Sometimes it'll get turned. It's just that the two legs are always congruent on isosceles triangles, and then the base is the odd man out. All right, and then the last thing, the base angles, they both touch the base. All right, so like these two are the base angles. They're always going to be congruent to each other. They're always going to, both touch the base. All right. So when we have two congruent angles, the opposite sides are going to be congruent, so we can set those equal. 12 equals x plus 3, so we subtract 3 on both sides. X is going to be 9. And one thing I want to point out, so right here, because this is a pretty easy problem, and there's one problem like this on the assignment that is a little more complicated, as in, like, you're going to set them equal, but then you have to solve, and I think because we're not solving here, people forget that this is an example that we've done. But this tells you the two legs are the same, so you're going to see an isosceles triangle where the two legs are the same. So all you have to do to solve for this is to set them equal. In this case, there's no solving to be done, but you know that y is equal to 50. So it would be the same thing if this was like 2x minus 3 and this is 3x plus 4. You would still just put an equal sign in between them and solve. But I think it just throws people off when there's x's involved and there's solving involved. But it's the same process. These two legs are the same, therefore their opposite angles, the base angles right here, are going to be congruent. I know they're not marked congruent, but you just need to know that those opposite angles are congruent on an isosceles triangle. All right, so y is going to be equal to 50. Then we look at this one. So for these problems, zoom this in a bit. Things that we know, we've got these legs right here, and we have these base angles. These base angles are going to be congruent. So if I know they're congruent, this is similar to the problem we did yesterday. So you actually dealt with an isosceles triangle yesterday. You just didn't know it was isosceles at the time, where two of the angles were the same. Same idea here. Are they both marked x? No, but you need to realize that they're both the same. So I can put an x on both of them since they're equal to each other. There's a couple different ways to solve this. One way is to set it up like this. X plus 100 equals 180. You can solve it like that. Get 2x plus 100 equals 180. Okay, and essentially solve it all the way down until x equals 40. Each of these angles are 40. Another way you could do this, if you don't want to set up an equation, you're pretty much doing the same thing without an equation, is just to take this 100 away from 180. So 180 is the total, subtract 100. You have 80 degrees left to split between these two. And so you just take 80 and divide it by 2, which is essentially, it's what we did here, but you can either use an equation or just do it step by step. 180 minus 100 is 80, and then cut that in half, you get 40. Both ways would work. But it's just whatever process that you want to follow. All right, and the main thing, you're going to be using the fact that all the angles of a triangle add up to 180 a lot today. So just make sure you know that. All right, then we look at this, and it's the same idea, except it's slightly different because now we have a more involved x value there. So it's 4x minus 2. So some different things that you can do. You can set this up as, like, both of these are 4x minus 2. But one thing that you can't do in this case, since these are the exact same, you can't set them equal. If these were different, then you could just put an equal sign in between them and solve. But that's not the case here. So in this case, we can add 4x minus 2, 4x minus 2 plus 20 and set it equal to 180. You can set this whole equation up and you can solve, or the other way you could do this, and I'm just going to put an or here, and on this side set it up in a different way. You can figure out what one of these angles equals first and then set 4x minus 2 to it. So it's whatever you want to do. I'm showing you different ways to do this because I don't know if there's necessarily a best way. I don't think there is. It's just a personal preference thing. So you can solve it like this. I just added the three angles together, set it equal to 180. Or you can take 180 and subtract 20 from it. Why am I doing that? Because I'm trying to figure out what one individual angle would be. And so I get 160. And then I realize, okay, I've got 160 degrees to split between these two angles. So 160 divided by 2 is 80. So you can realize, oh, this equals 80. 4x minus 2 equals 80, because this is 80, this is 80, that's 20. And then you can solve. It's the same thing that we did here. You're going to end up getting the same answer. It's like 20.5, I think, is your answer. Divide by 4 on both sides. X equals, yeah, it's 20.5. And then you should get the same answer if you solve it like this. 8x plus 16 equals 180. Just combined like terms. 8x, we're going to subtract 16 on both sides. 180 minus 164, and then divide that by 8, and you get the same thing, 20.5. But yeah, just two ways to do it. And remember, this is an or. It's not like you have to do both of them. It's whichever way you want to solve it, you're going to get the same answer. A lot of these, it's kind of like a puzzle. You take all the things you know about triangles and you solve it however you want. Whichever way you think is faster. It doesn't matter. And then same with this. Like, this is an exterior angle here, but I'm not going to use the exterior angle theorem to solve it. If you want to, you can. I think the easier way to solve it is to use the linear pair relationship, but it's up to you. These two add to 180. So 180 minus 114 is 66. So I can realize that this is 66 because this is a linear pair. Also, these are base angles. They're both going to be 66. Were they marked? No, they weren't marked congruent. I knew that they were congruent because they're opposite of the congruent sides. So you just have to be able to identify which angles are the base angles that are congruent based on where the congruent sides lie. All right, and then you can figure out, all right, what is angle 2? Because whatever angle 2 is, I can set it equal to that 4x plus 4. I don't know what angle 2 is just yet, but all I have to do is add 66 plus 66 to get, what is that? Is it 132? All right. Okay, yeah. So 132 is what these two angles are added together. Subtract 132 from 180, and I think it's 48, if I'm doing it in my head correctly. You get 48 degrees. So great, this is 48, but that's not our final answer. This one's kind of a tricky question the way it's laid out. It says that the measure of angle 2 is 48 degrees, or is 4x plus 4, which we know that angle 2 is 48 degrees. So we then have to set this 48 right here and set them equal. So this is a similar process to you're just solving for the angle, and then whatever that angle is, you set it equal to that x value. So here's where you can solve. So minus 4, 4x equals 44 divided by 4. And x is going to be 11. All right, shifting gears. We just talked about isosceles triangles. Now we're talking about equilateral triangles. This is a conditional statement as well as its converse. All right, so where we switch the hypothesis and conclusion. So if a triangle is equilateral, then it is equiangular. That is true. You take the converse of it. If the triangle is equiangular, then it's equilateral. That's also true. Meaning, all the sides are the same. If all the sides are the same, all the angles are the same. And backwards, if all the angles are the same, all the sides are the same. So you don't have to have both things marked because, you know, if one is true, then the other is. All right, things that we already know. The measures of three congruent angles in an equilateral triangle must add up to 180. We've talked about that a lot, and you've talked about it before in previous grades and previous math classes. But it's important to know. All right, then so each angle in an equilateral triangle measures, okay, if you have 180 degrees and all the angles are the same, you divide it by 3, you gotta equal 60, okay? And there's some problems on your assignment that I think people just are like, whoa, this is too easy. But it literally will just give you an equilateral triangle and ask you what the angles are, and you just have to type in 60. And people have been overthinking it today. Don't do that. It's just 60 degrees. So if you have an equilateral triangle, see all the sides are marked the same? And you are trying to find, you know, what these x values are, you know that each of these angles are going to be 60. Is it written on there? No, it doesn't say 60 anywhere. But you know they're all 60, so you can set each one of these things equal to 60 due to it being an equilateral triangle. So we're going to subtract 10 on both sides. And then we're going to set 3y plus 3 equal to 60. You're going to do this separately because we're not going to mix the x and y and have to do systems or anything. We know they're both equal to 60. 3y equals 57. Y is going to be 19. All right. And then when we look at this next one, there's 3 sides that are congruent. So it is up to you what you choose. There's different ways to solve it. You can choose, oh, I want to set 2y equal to 10. Okay, great. You're going to get y equals 5. But if you would get the same answer if you chose to set 2y equal to y plus 5. Because all the sides are equal to 10. They're all the same. So you should be able to set those equal to each other. So you subtract y on both sides. 2 minus 1 is 1. Y is going to equal 5. No matter what you do, y will equal 5. Because it's the same variable, and then no matter what you set equal to each other, they're all going to solve to equal the same thing because the variables are the same.